sound intensity. That's going to be our next topic. So what is this sound intensity all about? We learned about Doppler's effect, and Doppler's effect was all about the change in the frequency of the sound. Sound intensity is something which deals with the energy, sound energy. Now, for example, imagine there is this speaker, and there is a person standing very close to the speaker, and there is this person standing very far away from the speaker, from a higher at a higher distance from the speaker. This person will hear a louder sound, obvious, because when you are closer to the speaker. But when you are far away from the speaker, you will hear a sound which is less louder. Okay, why does this happen? That is what we are going to learn here. So you can't compare this with Doppler's effect. Both are two contrasting things, and here the objects will not be moving actually. So let's see what this is all about. So when it comes to sound intensity, we use the symbol I. The definition for sound intensity is sound energy emitted per unit area per unit time. That is how we define sound intensity. That is the definition, sound energy emitted per unit area per unit time. If you put that into an equation, this is how the equation is going to look like. Equation. And then let's convert this equation to symbols. But before that, we know when you divide energy by time, sound energy by time, what do we get? Energy over time is power. So you can convert it to power of sound, maybe power of sound divided by surface area or area. Normally we say surface area because sound is emitted through a surface, right? So surface area. This is the final equation for sound intensity. You put that into symbols. I equals energy over area into time. If not, you can say power over area in simple terms. This is how the final equation is going to turn out. Okay, we have introduced a new physical quantity, so we have to introduce the SI units, correct? So what about the SI unit of I? We are dividing power by area, so we normally use watt per meter squared. That is the symbol we use. If not, this is highly unlikely. Instead of watt, you can use joules per second per meter squared. That is also possible, right? And similarly, you can find the dimensions of I as we usually do. That is power over area. So what are the dimensions of power? ml squared t minus 3, and dimensions of area L squared. So you can see L squared and L squared will get cancelled off, and finally you will end up in mt minus 3. That is the other dimension. And sometimes you can write another what do you call that SI unit? mt minus 3 means it's kilograms second minus 3, which is hardly used. We never use it, but in MCQ sometimes they will ask choose the possible units for sound intensity. So these are the units, right? So that is all about sound intensity. Sound intensity solely depends on energy, actually, energy. Okay, so when energy increases, sound intensity will increase. Normally we say per unit area per unit time. So if you keep this one, then it actually depends on how much energy that sound source possesses. All right. So to put this into a better perspective, normally when you have a sound source, it will be like, let's say this is a speaker or a bell or a siren. Now we are observing that from a bird eye view, from a drone, from a satellite, and then what happens? Sound will be emitted like this in wave forms like this, right? This is how the sound is going to be emitted everywhere, and the circles I'm drawing are not actually circles. They have to be spheres. Everywhere the sound will be emitted like this. So from that particular sound source, when you take a particular distance r, let's say I'm just going to take a particular distance r. Okay, let's say there's a point. Okay, there's a point. So up to that point you can draw a sphere, a surface, spherical surface. You can just draw a spherical surface like this. I have not drawn the entire one. You get the idea, right? You can draw a spherical surface like that. And at that point, if you are supposed to know the intensity, you can always define intensity from a sound source. This dot is the sound source. It is at rest. Okay, and that sound source will have a particular amount of energy or power. We don't know. It will have a particular amount of energy. We don't have control over that energy. That depends on the sound source. So if you want to increase the energy, maybe you can increase the volume. Okay, we just studied in the previous tutorial, loudness is volume. Volume depends on energy. right? So this. So then at this point, there's a person. That person will be hearing that sound, and the intensity of the sound the person hears can be defined as, okay, power divided by area. And for area, what we can write is power over, for area, this is not a circle, it's actually a sphere. So you have to put the area, surface area of that sphere. The equation is going to be 4 pi r square. That is the equation for the surface area. And if you don't change the sound source, power is going to be constant. 4 and pi are anyway constant. So you can finally say I is actually proportional to 1 over r square. If not, I is inversely proportional to r square. That means sound intensity will decrease as the distance from the sound source increases. It's obvious. Imagine this is a speaker. You are very closer to the speaker, you will hear a louder sound. But when you are very far from the speaker, you will hear a very light sound. So that's obvious. That's how the sound intensity actually works. So I hope you understood that about sound intensity. Right. So now let me develop another equation based on this. Let's say there's a sound source like this, a sound source like this. From that sound source, there are two people at two different distances. So person 1 is at r1, a distance of r1, and the other person, if you take person 2, is at distance r2. All right. So this is person 1, this is person 2. Now this person will be hearing a sound, and that sound that person hears will have a sound intensity. And this person will be hearing a sound, and this person will also have a sound intensity like this. Okay, right. So let's try to find a connection between this I1, I2, R1, R2. What is the equation we just learned? Relationship we learned, I is proportional to 1 over r square. Okay, so one equation I can write, I1 is proportional to 1 over r1 square, I2 is proportional to 1 over r2 square. Okay, why am I using this? Because we are not changing the sound source, so that power is constant. Then if you combine these two, finally you will end up in, you divide the, right, okay, this, let's say this is number 1, this is number 2. When you divide the first one by the second one, you will be getting I1 over I2 equals R2 squared over R1 squared. If you can remember this equation, it will be really handy when you do MCQ questions. It will be really helpful for you if you can remember this equation when you do MCQs. No, this is how the MCQ questions are. We will discuss later. Normally, they will give you two different points, and you will have to compare the difference between the the sound intensities. Okay, that is how the relationship for sound intensity is. Right, fine. So I hope this part is clear. That is the normal introduction of sound intensity. Sound intensity is mainly a measure of how much sound energy is emitted from a certain place. Fine. So the next topic we are going to move to is called sound intensity level. Now let's see what sound intensity level is all about. Sound intensity level is another way of representing sound intensity. Now normally when you consider sound intensity, it has very small values, 10 to the power minus 10, 10 to the power minus 9, 10 to the power minus 8. When you say 10 to the power minus 8, you know it is 0.701. It's a very small value. So we use this quantity to represent sound intensity in another way. So just like we discussed in the earlier tutorial, from a certain sound source, now this is our sound source, correct? From a certain sound source, if you are at a certain distance, you will be hearing a sound. For that sound, we will be defining sound intensity as well as sound intensity level. Okay, right. So the definition for sound intensity level, we normally use the symbol beta for sound intensity level. Careful, sound intensity level. The definition for that is going to be this. Well, this is that equation. Beta equals 10 into log of this whole fraction, I over I naught. I is the sound intensity at a certain point of consideration. I naught is called the threshold of hearing. Okay. At 1000 hertz, if the sounds the frequency is 1000 hertz, the threshold of hearing is 10 to the power minus 12 watt meter minus 2. What is the meaning of threshold of hearing? If your sound has an intensity less than this, you will not be able to hear it. We learnt ultrasound, infrasound. We can't hear them. That is based on frequency. This limit is based on energy. Okay. Now a sound might be at 1000 hertz, okay, that is in your audible range, but still if the sound is very light, it's like imagine when someone is whispering, that means you can't hear it, but that sound might be at 1000 hertz frequency. So you have to be, two conditions must be satisfied. One thing, your sound must be within the audible range. Second one, it should have sufficient energy to be heard. Okay, this is that equation. Now when it comes to beta, it is 10, a number, then you say log, and then this whole log means it is another number again. Whenever you take log for a number, it is another number. So beta is actually dimensionless. Very important. We say beta's dimension of beta, we say 1. That means it is dimensionless, but it has a unit. Okay, SI unit of beta, we use simple D, capital B, we call it a decibel. That is the unit. This is the unit. So this is a very special quantity. It has unit, but it does not have dimension. Decibel, another or else sound intensity level actually. Or another example is angular displacement, theta. It has a unit, radians, but it does not have dimension. Right? We have discussed about this in what do you call that? We have discussed about this in units and dimensions as well. I hope you can remember. Now, since this is a new equation, let's do some let's try some examples. But before that, there's one more thing you have to know about this. Normally, we very rarely use this equation directly for questions. Normally what happens is they will give us two different points, and we will have to compare the sound intensity levels between two different points. So I will quickly give you an example. Let's say there's a sound source like we discussed earlier, and from that sound source I'm going to take 2 points at two different distances. Right. One is at R1 distance, one is at R2 distance. Hereafter, remember, whenever you come across these questions, you have to always mark two things. At this point, a person will be hearing a sound, and that sound will have an intensity, and that sound will have an intensity level. Here also, the person will be hearing a voice. If that's noise or sound, will have a certain intensity and the corresponding intensity level, both. I hope you understood. I'll take this point as 0.1, I'll take this point as 0.2. You have to always mark this, and then only you have to approach the questions. One thing we can quickly write, we have already derived it. We know that I1 over I2 is actually equal to R2 squared over R1 squared. I hope you can remember, we derived it little in the previous case, this relationship. If you can remember, it's very helpful when you do MCQ questions and all. Good, right. And then let's try to get a relationship between beta 1 and beta 2. Fine. So I'm going to apply this equation which we learned a little while ago for each point. So I'll write quickly the main equation. Beta is equal to 10 log I over I naught. All right. So when I apply this equation 0.1, that's going to be beta 1 equals 10 log I1 over I naught, and for beta 2, if I write this equation, that's going to be 10 log I2 over I naught, log of whole thing. Remember that first equation, second equation. All right, fine. Now since there is log here, you can't divide, because when you divide log by log, you don't get a proper result. But when there is log, you can add or subtract. So what I'm going to do is I'm going to subtract here. If you see this diagram, R1 is smaller than R2. That means 0.1 is closer to the sound source, so that I1 will be greater than I2. Similarly, beta 1 will be greater than beta 2. Why? When you're closer to the sound source, you will hear a louder sound. So this decibel is about louder sounds. Okay, right. I will give you more examples about decibel in a while. Please be patient. Right, now what we do is we subtract this. I'm going to subtract because beta 1 is larger. So 1 minus 2 will give you beta 1 minus beta 2. And on the right side, 10, it's common, right? Then inside log, you will get log I1 over I naught minus log I2 over I naught. So I have something like this. Okay. Right, then I'll use this again, beta 1 minus beta 2. Remember, always write the larger number here, beta 1 minus beta, then you will not get confused. 10, inside log you have log A minus log B. So what happens when you have a situation like that? When you have log A minus log B, in small classes you must have learned, you can write log A over B. Correct? And when it is plus, you can write log A multiplied by B. So here if you change that, you will be getting log inside I1 over I0 over I2 over I0. I hope you can agree with me on that. Then I0 and I0 will get cancelled off. And finally, you will arrive at this very important equation, which we will be using quite frequently under this chapter, log I1 over I2. That is the equation we're going to get, which is the most important equation when it comes to MCQ questions. Very frequently used. This is very frequently used. So you have to be absolutely sure about this. Okay, when you compare between 2 points. And if you want to develop that a little further, you can do something like this. Instead of we have log I1 over I2, now the whole thing. Instead of I1 over I2, you can substitute this. So that can also be written as 10 log within bracket R2 squared over R1 squared. If they are looking for a relationship for beta and R, you can write this directly. Okay. Again, if you knowing these equations are going to really help you when it comes to MCQs. If not, you'll have to do all these things and get this equation, and that is quite time consuming. So I really encourage you to remember these equations. So these are the 2 equations we have. Okay, fine. Then this is basically the theory part when it comes to sound intensity level. But let's see what this sound intensity level is all about in real life. So I'm gonna give you certain examples to understand what this decibel range, this decibel scale is all about. These are some these are certain sounds, different types of sounds, and the sound intensity levels, how loud that sound is. Okay, so this is the threshold of hearing, 0 decibel. If the sound intensity level is below 0 decibel, that means you will not be able to hear it. You can get negative values for this. Let's see how that works. Don't worry. And you can see whisper, it's just 10 decibel. Then rural neighborhood is relatively very quiet, 30. Then an urban neighborhood, 50. It depends. Suburban, just a neighborhood, 50. And normal conversation, 60. And then a passenger car, medium truck. Then you have jackhammer. Jackhammer is this drilling machine they have when they want to drill concrete. It's a very loud sound, no? And 120 is what you call the threshold of pain. If the sound intensity level is above this, it will create a pain in your ear, and there is certain value. I think it's 150 decibel or 130 decibel. If you hear a sound above that, sometimes it will rupture your eardrum. So those sounds are very painful and very harmful. 120 is the limit. So these 2 intensity levels are important. The 2 limits. One is threshold of pain, the other one is threshold of hearing. If the sound is above this, that sound will create a excruciating pain in your ear. If the sound is below this, you will not be able to hear that sound. I hope you get that. Now the conversation and all that can vary. It will depend, but this is the range. Okay, even whisper can be different. Sometimes it can be louder, sometimes it can be less louder. But using this, you get a general idea, right? How loud is that noise? How loud is the sound? That is what this decibel is all about. Fine. Now let's do a small calculation. Let's just they ask you to find out what is the threshold of hearing and what is the threshold of pain in terms of intensity, not intensity level. Now you know intensity level, correct? Fine. So these 2 are not that hard. I'll just put the number now here for this particular case. Sound intensity is actually 1 watt meter minus 2. That is the threshold of pain. If the sound intensity is above this, that will create a pain in your ear. And here, threshold of hearing, we have already discussed about that. It is actually 10 to the power minus 12, 10 to the power minus 12 watt meter minus 2. That is the threshold of hearing in terms of sound intensity, not intensity level. Now let's do a quick example so that you will get an idea about how to use this equation. That's very important. Let's say they have given you a certain sound. Okay, let's say a normal conversation. Okay, 2 people are conversing and there is a sound created. That sound has a sound intensity level of 60 decibel. They are asking what is the sound intensity of that sound. Okay, let's start. Now you obviously going to use this equation. Beta is equal to 10 log I divided by I naught. Beta is 60 equal to 10 log I we have to find over I naught is 10 to the power minus 12. Okay, right. So you know you can cancel out these zeros, so it will be 6 equal log of this. Okay, I'll write it again here. 6 equals log of I over 10 to the power minus 12. That is it. Fine. Now this can be converted to this. 10 to the power 6 is equal to I over 10 to the power minus 12. How did that happen? How did that happen? Let me quickly explain that here. Okay, guys. Now 10 to the power 2 is 100. Okay, 10 to the power 2 is 100. So when you say log 10, 100, that is equal to 2. Okay, compare now, compare. This 2 is here. Okay, and this 10 is the base, and is 100. Is 100. That is here. That's what I have done here. Try comparing those two. Whatever the number you have here, you write it as the power of 10. You write it as the power of 10 on the other side. Then you can get rid of this log sign. You get this. And then finally, when you multiply this, you will end up in I equals 10 to the power minus 6 watt meter minus 2. So you should know, they will give you a decibel value. Then you should know how to convert that to sound intensity. They will give you a sound intensity level. You know how to convert it to sound intensity. But if they give you sound intensity, and if they ask you to find decibel, it's very easy. You will substitute the value here, get the answer, and multiply. It's very easy. But this might be a bit challenging because this particular step is going to be crucial. It's not that hard to understand. Try to relate this to this, then you will get it. It's very important that you have to know this case. Okay, right. And here I have written something, that is the threshold of hearing at 1000. I have written at 1000 hertz. So this value for threshold of hearing is not for every frequency. Normally it is for 1000 hertz. So there is a difference, there's a relationship between the sound intensity level and frequency that is actually represented by a graph. So that is the last part under sound. After that we can conclude the lesson sound. So I think you should know, you should have an idea about that graph as well. Let's quickly discuss about that graph. This is how the graph actually looks. Okay, so this graph is for sound intensity level versus frequency, and there are two lines. Probably they will give you this graph at the exam, so you don't have to panic. And there are two lines. This line is how the threshold frequency varies, threshold of hearing actually. Threshold of hearing varies with frequency. Okay, so this is now 100, 1000, 10,000. This is called a log scale, not the normal scale, because look at the gap, 100, 1000, same gap, but this is not that. This is log scale, because when you take log of 100, what is log of 100? That is log of 100 is 2. And what is log of 1000? It is 3. I hope you understand what I'm trying to mean here. Log of 10,000 is 4. So that is the scale here. 1, 2, 3, 4 log scale. We call it a log scale. So these 2 points are the important points. We already know these 2 points. This is the threshold of hearing. This is the threshold of pain. 10 to the power minus 12. Sorry, 10 to the power 10 to 10 is 1 actually. This is 1 watt meter minus 2. And this is 10 to the power minus 12 watt meter minus 2, the threshold of hearing and threshold of pain at 1000 hertz. These are the normal values we use, but for different values it will be different. Now when they give you a graph, they will sometimes say the frequency of the sound is 100. When the frequency of the sound is 100, you will go to this point and then will go here. Then based on the graph scales they have given, you will find the value. So that is the value you have to use for I0, not this value. If they have given this graph and if they are asking questions. If they are not given the graph, then they will definitely give you this value, 10 to the power minus 12. Don't worry. So this is how, and then when you connect these two lines, you get this area, which gives you the audible range. Where this is the range of sounds which can be heard without pain in the ear. Okay, different values can be considered here. So this is not the only line they will give. There will be other lines sometimes, but these are the two extremes. Below this you can't hear, below this line you can't hear, above this line if you hear it will cause pain in your ear. Okay, so this is the relationship between sound intensity level and frequency. I just wanted to clarify that that 10 to the power minus 12 is not for all the frequencies. Sometimes now here for this frequency also it is 10 to the power minus 12. That's another thing. But anyways, hope you get there. Again, this one, see, now at two different frequencies we get the same threshold of hearing, right? That also, you know, some possibility, but just have an idea about this because this is included in your syllabus, the last part, and I have given you a rough idea. And they will probably give you this graph, and based on the graph you will have to do the questions. Okay, so with that we are done with the theory parts for sound, but knowing the theory part is not sufficient at all because the application of this theory for question is completely different. So you need a lot of practice when it comes to questions. So you should try a lot of MCQs, and then only you will be able to get a hold of this theory part. So let's discuss the questions one by one. Well, maybe the last 10 years because there are a lot of questions in waves in past papers. So if you are going to discuss many years, it is going to take a lot of time. So let's discuss as much as possible.